Let's dive into the inner workings of a key component in diesel propulsion, the fuel injection pump, specifically the ZTUOAUMA 7 watts -5932, also shown as 7W5932. This unit is offered as a compatible replacement for a range of Caterpillar machines and engines, including the 3306, 235C, 235D, as well as equipment models like the 330L excavator, 621S, 637E, 615C, 621E tractors, and trucks such as the 65B Challenger, along with related variants like D25D, D30D, D300D, D350D, etc. In this breakdown, we'll explore what makes this pump tick, where its strengths and risks lie, and how one might evaluate it when considering a purchase. Start by acknowledging the importance of the injection pump in a diesel engine. Its mission is to draw fuel from the storage source and deliver it under extremely high pressure into the fuel lines going to injectors. That delivery must be timed just right and metered precisely. In heavy machinery, where loads vary, operating environments are harsh, and reliability is non-negotiable, the pump must perform consistently under stress. Any mismatch or subpar component can lead to poor combustion, excessive smoke, loss of power, instability, or worse, component damage downstream. This particular pump claims compatibility with a broad set of Caterpillar engines and machines. That wide claim compatibility is attractive, especially for operators or restorers working with older fleets where parts may no longer be OEM available. But compatibility claims must be validated carefully. Fitment, precision, internal components, and tolerances matter deeply. Begin with the outer appearance and structural precision. First impressions carry weight. Inspect the casting. Are seams neat, flash minimal? Are bolt holes clean, aligned, and free of irregularities? Are all surfaces that mate with gaskets or seals flat and smooth? These attributes offer early clues to manufacturing quality. If the external geometry is sloppy, there's reason to suspect internal quality may also suffer. Next, focus on interface and mounting. Even if the pump is labeled compatible, it only matters if every critical dimension matches. The mounting flange geometry, spacing of fasteners, shaft coupling or splines, input shaft alignment, and orientation must all replicate or fully align with your existing pump. Mismatch in even one dimension may force adapters, modifications, or worse, misalignment under load. Once the external and mounting geometry checks out, the internal architecture becomes the centerpiece. The internal parts, plungers and barrels, delivery valves, springs, seals, internal passages, determine how well the pump performs under pressure cycles. Plungers should be smooth, polished, and free of scoring. Barrels should maintain tight clearances. Springs should have consistent, repeatable force. Delivery valves should seat perfectly, without lapping or leakage. Seals need to resist fuel, heat, and vibration. Any blemish, pitting, or inconsistency is a red flag. Then comes adjustability and calibration potential. Even the most precise pump design often needs fine-tuning upon installation. That means the design should permit setting rack limits, adjusting timing or spill ports, and tweaking delivery if needed. If the replacement pump is rigid, without any adjustment slack, it may become very difficult to dial it in under real engine conditions. Service life and robustness under real conditions is the final frontier. In the dusty, high-temperature, vibration-intense environments typical of heavy machinery, how well will this pump endure? One must consider wear margin, surface hardness, corrosion resistance, and the pump's resilience to imperfect conditions. A well-designed pump may survive years of service, a borderline one may degrade quickly. Here's a suggested checklist when deciding whether to use such a pump. Verify the original pump's part number. If the existing pump is marked 7W